All right, for our second example, we have a piece of cardboard that is 12 by 10 inches, and we're cutting out squares that are side lengths x from each of the corners, okay? We want to determine the volume formula and find the max volume formula, and we want to know what size those squares would be. Okay, so if we draw the picture that represents this scenario, we have one here, okay? And we want to write the function. Well, since we're trying to create a, um, a rectangular open box, then you know that volume is length times width times height. Well, if we look at this, since the entire thing is 12 by 10, but it cuts out two x's, our actual length, is just 12 minus 2x. And our actual width is 10 minus 2x. And then our actual height is just x, right? So that means that our volume formula, length times width times height. And now we just want to put it in standard form, so you want to FOIL everything out. And if you FOIL everything out, you should get 4x cubed minus 44x squared plus 120x. All right, and now we want to go through the process of differentiating the function. So if we do that, we get 12x squared minus 88x plus 120. And now to find the critical numbers, we have to set it equal to 0 and solve for x. So if we go ahead and factor out the 4 of a GCF, we're left with 3x squared minus 22x plus 30. But then what happens is, if we try to factor this, that would be 90 and negative 22. There are no numbers that multiply to 90 that would add to negative 22. So that means in this case, we have to use our quadratic formula. I can go ahead and divide off the 4 so that I don't have to deal with big numbers. So if I do that, then, it's negative b squared plus or minus square root of b squared minus 4ac all over 2a. So that means that'd be positive 22 over 22, or under 22 squared minus 4 a c all over 2 times 3. Okay, and so then if I plug that in the calculator, I'll get, rounded to a couple decimal places, I'm going to get about 1.81, and I'm also going to get about 5.52. And so now we want to test the critical numbers. And again, remember, you don't want to go before 0 since these are applications. There's no such thing as a negative side length. Okay, and so now if I do a test point where I test in, let's say maybe I test in 1, and then let's say test point 3 and test point 7, and you want to plug it in to the equation there. You just want to see if it's positive or negative. The first interval is going to be positive, and then negative, and then positive, right? So that means I am increasing and then decreasing, so that is indeed a maximum. My next one, though, I'm decreasing and then I'm increasing. That's at a minimum. The question did not ask anything about wanting to know a minimum. It only wanted to know the maximum possible volume. So that means we're going to go with x equals 1.81. Okay, so that already answers part of our question because our squares were x by x, right? So that means that our squares that were cut out, had dimensions of 1.81 inches. by 1.81 inches. But then it also wanted the max volume, so we can find the max volume by plugging it into that volume formula, V of x. So if I find V of 8.81, then I will end up getting 96.77 inches cubed if I just plug it into our volume formula. Okay, so it said what size are should the squares be to cut the box to create a maximum volume, and it asked what the maximum volume is. So therefore, those are our two answers there. And that is scenario 2.